Yeah.
And funny. I know.
We are recording.
Hey guys.
Right, welcome to dull lesson. No, not be done. Okay, we are talking function notation. Now, you've probably already all done this. You've done it in IGCSE, so it's just a check that you know what you're talking about. Right, just fill in the gaps. Now, there are two things really that you have to do with functions. Okay, so you either substitute into a function, right, or you solve a function or an equation. Okay. Now, I'm going to ask you, do you know what that means to substitute into or to solve a function? Can you give me an example of a situation where you'd be substituting into a function and what you're doing? No? Yeah, so for instance, I might say, so again the vocabulary is important. What is the value of 2x plus 3 when x equals 6, for instance? Would be the kind of question that you might do in a very simple case. And in that case, you would do 2 times 6 plus 3. So it's the substituting in, so it's x. Is it always x?
Not necessarily, because the x is just the value that it gives for the input.
Yeah.
It doesn't necessarily have to be x unknown. It's just a value of the
So
input.
we're talking, like I said, it's input into the function. Remember function machines, and that's talking output. So that's the way we're going, right? So in this case, we've got two components to this, two operations to this function, right? But when we are inputting, if we're substituting in, that's what we're doing. We're going from input, finding the output. So what is solving a function? So give me an example of the kind of question you'd be asked to do.
Well, you need to find x, so you put 0 as your y.
So yeah, find x maybe. Every time I write that, I think of the joke exam question. You've seen that one at all? Yeah. Find x. Here it is.
Oh, have you read that book? The one of like.
No, I read it on the internet.
I haven't.
I'm not
I
as
read
educated
some of them.
as books.
They're really funny.
Yeah, something good actually. There's one about the physics. Set up an investigation, and they stuck an elephant at the bottom of the slide or something. Anyway, find x. So what we're doing then, example would be, for instance, if 2x plus 3 was equal to 15, find x. So in this case, we're kind of going the other way. So we would start with our output, okay? We would think about the function, and we are trying to find the input. That's what we're trying to work out. That's what's solving. So basically only those two things that we have to do. We either substitute in to find a value, so that's an important word, or we have to solve, find x. I could say find x by solving and so on. Alright? Now, if I do this way, I put it into a function. If I'm doing it this way, basically I am doing the inverse function, which we will also have to look at. But right, we're doing the inverse function. Now, when doing those two things, there's an awful lot of stuff that is involved. For instance, factorization, simplification, collecting like terms, all that sort of stuff is just a way of making it easier to either substitute or solve. Okay? So when we're dealing with functions, this is all it is. You either substitute in or you solve. Either way, but you might need extra skills to make that possible. So we need to think of that when we talk function notation. Now, just before we do a bit more function notation, there is one other thing we need to consider, which is a graph. Right? So, for instance, if I were to do this, so it's a kind of, what would you recognise that as? A cubic. Yeah. So that function is cubic. Now, can I ask you, please? Now, what is a graph? Because I don't think everyone knows what a graph is, or they do, but they don't really think of it, and then it doesn't make so much sense. So what's a graph? A representation of a function. What do you mean by that? So representing what?
When you put in the input value,
Yeah.
the output you
Yeah. So this is the thing. If I pick a point here, the coordinates might be, I don't know, 4, 3. Alright, so it's a coordinate on function. Now what that means is, as we've taught functions, that 4 goes into the function, whatever it is, and 3 comes out. So it's important that you can also use graphs of functions. Alright, it's nothing different. Alright, because it's the same thing, you don't need any new skills. Right? Now, function notation. So, you will recognise if I say f of x equals 2x plus 3, whatever that's that. Nice and simple. So how would you read that to someone and explain what it means? Anyone?
Well, it's the f of x. The f, I think it represents for function. It's another way of expressing. The following function is equal to.
See, I would read it like this. The function applied to x is 2x plus 3. That's how I would be reading that. Okay, so 2 ways to use that notation. Okay, find that, solve that. So because you know there are 2 things to be done, actually now it shouldn't be too difficult to think, well, what is it I have to do? So if I said to you, find that, Michelle, what would you think that means? Think of function notation. What have I replaced here? What? The x has been replaced by 3. So, yes, exactly. So that will equal 2 times 3 plus 3. Okay, so if I substituted the x for the 3, that's what I'm doing. I'm substituting. Right? If I say solve f of x equals 7, what am I going to be doing?
2x plus 3 equals 7.
So 2x plus 3 equals 7, and I'm going to solve that. So I could be saying find, if I want to do more vocab, find the value of f of 3, or it says solve f of x equals 7. So the value of f of 3 equals 9. Okay. And f of x equals 7 when x equals
2.
Easy. No problem whatsoever, no? Right. If I were to ask you up here, find f of 2, and I've given you a graph, what would you do there? Nikita, what would you do?
You look on the x-axis for 2 and read up and then read across.
So I pick 2, I would read up, find that point, and then read across, and that would be f of 2. Okay. If I said to you, solve f of x equals 6, Evgeny, what would you do? Using the graph. No idea? Better listen when Nikita tells you then.
So fx is the y value.
Yeah,
We go up the y-axis until 6.
yeah. So let's say it's roughly here. And then
We go across the line
go across
and
and down. Okay. So that will be when f of x equals 6. Okay. Now, just to one more thing from graph, if I said to you f of x equals k has 2 solutions, okay, and if I said to you state k using this chart, what would you, how would you do that? So, go on, George.
Well, the k is like another way of expressing constants. Then for 2 solutions, you're looking for the functions that gives 2 solutions.
So we're looking at this kind of format,
Yeah.
f of x equals 6.
Yes, so you look at like where the graph, like in the coordinates of the y,
Yeah.
values, where it like has 2 solutions when you cut across
So when I cut across it, it should touch the graph
twice.
twice. So I know that there has 2 solutions because
Touches it twice.
touches it twice. So it touches it there and it touches it there.
Isn't it on
Yeah, and it also, which is important, I'm glad you pointed out, it actually has,
Yeah.
there are 2 values of k, no? Yeah, here, yeah. So this is one value of k, this is another value of k. So there will be state k, and there we should say there are 2 k values to state. Right? Between those 2 values of k, how many solutions are there?
0.
3.
No, as in solutions for this question.
So between those 2
No,
k
no.
values,
What I was saying is that between them, it cannot be.
K. It can't be K. It says K.
It cannot
I said how many solutions rather than how often is there 2 solutions.
Yeah.
I've said how many solutions will there be between the 2 values of k. So I'm looking for in this region, okay, between those 2 values of k, how many solutions will f of x equals that value give? 3, because it will cross the line 3 times. So it'll be, once, twice, 3 times, anywhere within those regions. If I go outside of k, above that k, below that k, how many solutions? 1. Okay, so when you get given a graph, it might be that you get asked that. You'll definitely get asked a question like that. Okay. All right. So things just to recap very quickly. Function notation. It is just substituting or solving, looking at the way it's written. right? Maybe we can do it using a graph, maybe we do it algebraically, right? Why do you think we have function notation? Any ideas? Why don't we just write the functions over? Why don't I write y equals 2x plus 3 all the time?
Well, the f of x, it's possibly like, maybe not to confuse you too much, like thinking maybe graph-wise. I mean, for instance, think about for straight line graphs, you'd go through the assumption y equals mx plus c. That's straightforward, but I think the f of x just clarifies that you're looking at a function, you're not looking at any type of graph.
Well, I wouldn't go that because the function can be applied to any type of graph. Yeah, f of x can be any function. Okay, it is. I mean, go on.
You combine functions as well.
You can combine functions. It's really like in the objective. It's function notation, so it's just a way of writing. That's all, without having to write out everything all the time. So, for instance, you get to a point where you might say, well, I've written f of x is, all right, do I have to keep writing what f of x is, or can I just write f of x? You know? So, for instance, f of x equals 2 is nice and simple to write, whereas if f of x equals x squared plus 4x plus 3, you know, I can say f of x equals 2 rather than that equals, and I can list a whole set of questions now. I can go f of x equals 2, f of x equals 1, f of 3, f of 2, and then plus 4. I could say f of 6 plus f of 3 equals, right? So it's a quick way, it's a shorthand. Right? The next thing I want to point out is, what if you want to use two functions in your same piece of writing, for instance? So I've got f of x.
House.
What if I want to have a second function? Any idea?
Is it the fx, like the brackets?
No.
So,
Yeah. So if I've used f of x and I want to apply a different function to x as well, I would do g of x. And if I have a third one, h of x, and so on. Okay? If I'm in physics, if I'm in a physics lesson, I might not have f of x, I might have f of a function of acceleration. I might have f of d, I might have g of s, and so on. It's the same notation. If I were to write f of a, what kind of function might I have then? What might come after f of a equals... Let's give the actual function. Pardon? Yes. It doesn't matter, it doesn't have to be an actual physics one. Let's pick a linear equation. What would you say? F of a would look like what? 2a plus 7. That's important. F of d would look like d squared plus d plus 3, for instance. G of s would be 3s cubed plus 2s, and so on. Okay? So if you have a letter within the brackets, you carry on using that letter. Alright? So then I know, actually, f of x and f of a. Well, if f of x is x squared plus 4, what is f of a? A squared plus 4, because it's the same function but applied to a different input. Alright? Make sense? Okay. So what I'm going to ask you to do now, just for a bit of practice, it won't take you very long. Alright? Page 13. So we're looking at page 13. Simple stuff. you've got exercise 1E. I want you to go through those questions. Sorry. Exercise 1, so it's page 13 and page 14. Make sure by the end of this, so I've got 15 minutes, that you have definitely had a go at the exam style questions at the end of those two things. Right. So maybe not do all of them, but check that you can go through it. Right. So page 13, exercise 1E, make sure that you have done, along with others, the exam style questions. Okay. And then 15 minutes we'll move on to composite functions.